Okay, this is the second video for Unit 7 over balancing equations. So when you're balancing chemical equations, the first thing that you're going to think of is, why are we doing this? So when you're talking about balancing, you're referring to the law of conservation of mass, which states that mass is neither created nor destroyed. And basically what that means is, in a chemical reaction, you know that you have reactants and you have products. And the amount of reactants that you start out with should be the same amount of products that you end up with. Now, the reactants and the products are different. You're rearranging things, but the amount of matter that you start with is the same amount that you should end up with. So when you're referring to the law of conservation of mass, you have to refer to a very important scientist in chemistry. His name is Lavoisier, and he was a French nobleman that experimented with many chemicals, but when he was discovering the law of conservation of mass, he was particularly focused on metals. And what he did is he noticed that whenever he heated metals, they actually gained mass. And he knew that that mass just couldn't come from nowhere. It had to come from somewhere. And when he kept doing his research, he realized that it was reacting with the oxygen in the air. So for example, if you were going to heat up a metal like magnesium, and it would react with the oxygen in the air, it's going to gain mass because it's bonding to another element. You're actually going to be doing this experiment next week, so you need to be familiar with this concept. So when we are balancing chemical equations, there's a very important note that you need to make, and that's how you actually have to accomplish this. There's only one way that you can balance a chemical equation, and it is by adding a whole number coefficients. Coefficients are numbers that we're going to write in the front of chemical formula. So for example, H2O is a formula that has 2 hydrogens and 1 oxygen. If you were wanting to add more hydrogens or add more oxygens in order to balance, the only way that you can do this is by adding a number on the front right here. And so say we wanted to double the amount of hydrogens and oxygens we had. We could add a 2 in the front of this, and that means we would then have 4 hydrogens and 2 oxygens, because you're going to multiply this with all of these subscripts in the formula. So one important note that you want to make is that you cannot alter the formulas. You cannot add numbers to the formulas, and you cannot change the numbers in the formulas. The only thing you can do is add these coefficients. So I'm going to work out a couple of examples, and I do want you to copy down the formulas exactly as they appear right here in green, and then add in the coefficients along with me as I'm balancing these. So we're going to go ahead and balance the very first reaction. It's calcium and nitrogen to make calcium nitride. If you notice, you're going to see that we have 1 calcium here, 2 nitrogens here. And then on the other side, we have 3 calciums and 2 nitrogens. They have to be the same amount on both sides of this arrow here. And so if you notice, we have 2 nitrogens on both sides, so the nitrogens are already okay, but it's the calciums that are out of balance. So we have 3 on the right, and so on the left, we have only 1. So we need to add more on the left side. Now, this is an imaginary 1 right here, and so we have to put a number in front of calcium that will multiply with that 1 in order to make it the same number as the other side. And so in order to get 3, you have to do 3 times 1. So we're going to add a coefficient of 3 in front of that. Now the equation is balanced. For this next equation, we have potassium chlorate produces potassium chloride and oxygen. So the first thing I do when I do these equations is I look to see if what's out of balance. And if you notice, the only thing that's out of balance are the oxygens. We have 3 on the left side and 2 on the right side. When you have that situation where you have 3 on one and 2 on the other, you're going to both make them equal to 6. You're going to multiply them by each other. So we're going to add a 2 right here, because whenever I do that, 2 times 3 will give you 6. If you go to the other side, you add a 3 right here, because 3 times 2 will also give you 6. So now you have 6 oxygens on both sides. The problem with adding this coefficient here is that I changed the number of oxygens, but at the same time I also changed the number of potassiums and chlorines. So now my potassium and chlorines are not balanced. So I have 2 of each on the left side. So if I look back on the right side, I can add a 2 here. That way I will now have 2 potassium and 2 chlorines. So now the equation is balanced. Okay, for the next one we have sodium and bromine produces sodium bromide. So the first thing I see is that my bromines are not balanced. So on the right side I need to add more. So I'm going to add a 2 here in order to get 2 like there is on the left. I now have 2 bromines, but now I also have 2 sodiums. So I'm going to go back to the left side and look at my sodiums. My sodiums, I only have 1. So I'm going to go ahead and put a 2 here because 2 times 1 will give me 2 on both sides. Both of them are balanced, and one thing I want you to take note of is some of you are wondering what are we going to do with these blanks here. Remember, the only number that is invisible to us in chemical formulas are 1s. So if you want to, you can fill in these blanks with 1s. If you don't, you do not have to, just to answer any of those questions of what we do with those blanks. Okay, so in the next one, this one's a little bit tricky. When you have, what I see first is that we have polyatomic ions. And whenever you're dealing with polyatomic ions, it would make your life way easier if you treat them as one thing. We're going to look at SO4 not as 1 sulfur and 4 oxygens. We're going to look at that as 1 sulfate. We're going to treat it as one thing. So what we're going to do is we're just going to circle them. I see sulfates, I'm going to circle them and treat that circle as one thing. So on this side, there's no number outside of that circle, so I have only 1 sulfate. But on the other side, on the right side, I have 3 of them because that's on the outside of the parentheses or of the circle. So I'm going to fix my polyatomic ions first, and then I'll look at the rest of the elements and fix those if I need to. So we are short on the left side, so we're going to add a number in front of sulfate on the left side, and in order to make them the same, we're going to add a 3 here in order to get 3 sulfates on both sides. Now when I did that, I also changed the number of hydrogens. I now have 6 hydrogens on the left. So if you look back to the right side, I only have 2. So in order to make those the same, I'm going to add a 3 here. So now I have 6 hydrogens on both sides. But when I did that, I then messed up my oxygens. I have 3 oxygens on this side, but if I look back on the left side, I already had 3 oxygens. So I ended up not creating an issue and actually fixing something that I would want to fix later on. So our oxygens are fine, hydrogens are already fine, sulfates are fine, and then if you look, so are your irons. So if you want to, we can fill in the rest of these blanks with 1s. You don't have to if you don't want to. Alright, last 2 examples. The last 2 examples are what are known as combustion reactions. They are probably my favorite type of chemical reaction because you get the most fun out of these. Combustion reactions are easy to recognize because they kind of look the same. If you notice, these 2 reactions are very different, but they have kind of the same skeleton. They always have some sort of carbon-hydrogen-based substance. It's the fuel source. That is going to burn in the presence of oxygen gas, and it's going to create the same 2 products for every combustion reaction, carbon dioxide and water. So if you notice, the products kind of give it away as combustion, but it's some sort of carbon-based fuel burning with O2 to make CO2 and water. Now, whenever you see these reactions, you need to use what's called the Cho-2 rule. The Cho-2 rule makes combustion reactions easy to balance because some of them are very, very difficult to balance. The Cho-2 rule is you need to balance out your carbons first and then balance out your hydrogens. After you balance out those 2, attempt to balance out your oxygens. If you can't balance out your oxygens, then what you're going to do is you're going to double the coefficients. You're going to multiply them all by 2 in order to go back and balance out the oxygens. So let's work out an example of that. So on this first one, we're going to follow the Cho-2. So we're going to make sure first that carbon is balanced. I have 1 on both sides, so it's okay. Now I'm going to look at my hydrogens. I've got 4 on the left side and only 2 on the right side. So I'm going to add a 2 here in order to get 4 on both sides. Now I'm going to look at my oxygens. I have 2 on the left side, But if I look, I now have 2 here, but I also have 2 from the water. So I actually have 4 oxygens on the right side, but I only have 2 oxygens on the left. So in order to fix that, I'm going to come over here and add a 2, and I now have 4 oxygens on both sides. In that situation, if you notice, we didn't run into an issue with the oxygens, and so we didn't have to double the coefficients. We're going to run into that problem on this next example. So again, we have a combustion reaction, and we're going to use the Cho-2 rule. So looking at your carbons, I have 2 on the left, only 1 on the right. So I'm going to add a 2 here in order to balance out the carbons. Move to your hydrogens next. I have 6 on the left side, but only 2 on the right side. So I'm going to add a 3 here in order to have 6 hydrogens on both sides. Now, I have 2 oxygens on the left, and so let's come over here to the right and count those up. Remember, you've got these from CO2, but you also have these from water. So we've got 4 oxygens here, 2 times 2, plus another 3. So I end up with a total of 7 oxygens on the right side. So if you come back on the left side and you're like, okay, so let me add a number here that'll multiply with a 2 to make 7. There is no whole number that you can multiply by a 2 to get to an odd number. So this is where we're going to double all of the coefficients. What you're going to do is you're going to ignore the coefficient in front of oxygen. You're going to leave it alone for right now because you don't know this one right now. You're going to look at the other ones and you're going to double them up. This is an invisible 1, so we're going to double that up and make it a 2. This one is a 2, so we're going to go ahead and make that a 4. This is a 3. We're going to double that up and make it a 6. So yes, this is getting a little messy. So now let's go back through. If you want to double check, your carbons and hydrogens are already balanced. You just doubled everything up, so they're still balanced. Our only problem is our oxygens. What you just did here is you have now made an even number of oxygens on the right side. 4 times 2 will give you 8, plus another 6. So now we have 14 oxygens. If you come back to the left, there is a number that you can multiply by 2 in order to get to 14, and that is 7. So the coefficients end up being 2 to 7, 4, and then 6. We're going to work out a couple of those tomorrow in class. So if you're still confused on that, just hold off on those questions. No summary for this video.